welcome to the deep dive. So if you ever thought about, getting into programming, you've definitely bumped into Java.
Oh, absolutely. It's everywhere.
Right. It's this huge powerhouse language, super versatile, powers everything from mobile apps to like massive company systems.
It really does. The scale is incredible.
But let's be real, if you're just starting out or maybe just curious how it all works, Java can seem a bit daunting.
Overwhelming is a word I hear a lot. It's like walking into this giant library, right? Where do you even begin?
Exactly. And that's why today our mission is to kind of cut through that initial feeling.
Make it a bit more approachable.
Yeah. We're doing a deep dive into Java 9, specifically 5 key features that came out back in September 2017.
And these weren't just small updates. They were really aimed at making Java more organized, easier to pick up, and frankly, more powerful for you.
Right. Whether you're that beginner we mentioned or even a seasoned pro just catching up, we want to unpack these ideas, make them clear without getting totally bogged down in code examples.
And we're drawing our insights today from a really useful guide called Java 9 Features, a beginner's guide.
Ah, okay.
It lays things out nicely, what each feature is, why it matters, and how it helps, the person actually using Java.
Sounds perfect. So we'll be hitting 5 main things today. The Java Platform Module System, JPMS, that's a big one. Then JShell, private methods and interfaces, factory methods for collections, and the process API updates.
Each one, offers a pretty significant improvement, especially if you're interacting with Java in any way.
Okay, let's kick things off with maybe the headline feature of Java 9, the Java Platform Module System, or JPMS.
Right.
Now, module might sound a bit technical if you're new. How would you sort of explain what JPMS actually is?
Okay, think of it like this. JPMS is basically a new way to organize your Java program. Instead of one giant blob of code.
Which can happen easily, right?
Oh, yeah. Instead, you break it down into smaller, well-defined pieces called modules. The analogy in the guide is great.
Imagine a big puzzle.
Instead of all pieces scattered, you group related ones into labeled boxes. A module is like one of those boxes. It holds specific parts of your program. And crucially, it clearly says, okay, I need stuff from that box, and I'm willing to share this stuff with other boxes.
That makes a lot of sense, grouping the puzzle pieces. So this boxing system, why was it needed? What problems existed before Java 9 that this solved?
Well, before Java 9, especially in large applications, things could get really chaotic. All the code was often just lumped together in what's called the class path.
Right.
And it was super hard to tell which part of the program depended on which other part. This lack of clear boundaries led to all sorts of issues.
What kind of issues?
Things like JShell, where you had conflicting versions of libraries, hard to debug errors because changes in one place unexpectedly broke something miles away, and slow startup times because the system often had to load way more code than it actually needed.
Oof, yeah, that sounds messy.
JPMS tackles that head on. It forces you to define clear boundaries and dependencies between these modules, makes the whole thing much more manageable and much more robust.
So if I'm using Java, maybe starting a new project, how does this organization actually benefit me? What's the payoff?
The payoff is pretty significant. First, your programs become more reliable. Because dependencies are explicit, you avoid many of those runtime surprises.
Fewer unexpected breaks.
Exactly. And they become more efficient. Since you only package and run the modules you actually need, programs can use less memory and start up faster.
Ah, okay.
And this actually enabled a huge thing, tools like JLink. This lets you create custom, minimal Java runtime environments containing only the platform modules your specific app needs.
Wow, so you don't ship the entire Java platform anymore.
Precisely. This was massive for things like microservices or cloud deployments where small size and fast startup are critical. It made Java much more competitive in those areas.
Yeah, and updates.
Much easier. You can update or fix one module, one box, without worrying so much about breaking everything else. It's like rearranging just one part of your storage room. Much less disruption.
Okay, that modularity sounds like a really fundamental improvement. Let's switch gears to something maybe more immediately fun for learners. JShell.
Ah, yes, JShell. Great tool.
What is this thing? A digital scratch pad, you called it.
Yeah, that's a good way to put it. JShell is an interactive tool. You type a little snippet of Java code, hit enter, and boom, you see the result immediately.
No compiling, no saving file.
Nope, none of that ceremony. It's a REPL, read, evaluate, print loop. It reads your input, evaluates it, prints the result, and loops back, waiting for your next command.
It's like having a conversation with Java.
Exactly.
Right.
You can try things out, experiment, get instant feedback. It's fantastic for exploring the language.
So before JShell existed, What was it like just to test, say, one simple idea in Java? Paint that picture for us.
Oh, it was definitely more involved, even for the tiniest tests, like how does the string function work? You had to. 1, create a new Java file. 2, write a full public static void main method.
The standard entry point.
Right. 3, put your little test code inside that method. 4, save the file. 5, open a terminal. 6, compile it using javac.
Wow.
And then 7, run it using Java. All that just to see one result.
That sounds tedious, especially for a beginner just trying to figure out basic syntax.
It really was. It created this barrier to quick experimentation. JShell just completely removes all that friction.
So for someone just dipping their toes into Java, how does JShell make that learning curve less steep?
It makes learning interactive and, honestly, more fun. You can practice concepts immediately without the whole project setup hassle.
Just try things out?
Yep. Got an idea, type it in, made a mistake, you see it instantly, you fix it, you try again. It encourages exploration.
Like maybe testing how to store a name or do a quick calculation?
Exactly those kinds of things. Or figuring out how an if statement works or playing with a loop. It lets you build understanding and confidence piece by piece without the overhead.
And I guess even experienced developers find it useful.
Oh, absolutely. It's not just for beginners. Need to quickly test a complex regular expression or figure out how a method in some new library works. JShell is perfect. Faster than setting up a whole test project. It's become a standard tool for quick prototyping and API exploration.
That makes sense. Quick iteration for everyone.
Ah.
Okay, moving on. Let's talk about something a bit more under the hood, but important for clean code. Private methods in interfaces.
Right. A subtle but powerful addition.
First, maybe just a quick refresher.
Yeah.
What is an interface in Java?
Sure. Think of an interface as a contract or maybe a to-do list for a class. It specifies what a class must be able to do, but not necessarily how.
So like a vehicle interface might say, all vehicles must be able to start and stop.
Exactly. Now, before Java 8, interfaces could only declare these method signatures. Java 8 added default methods, which let you provide a standard implementation right there in the interface.
Ah, okay, so you could provide a default way to start the vehicle.
Correct. But what if you had, say, 2 or 3 default methods in your interface, and they all needed to use the same little helper logic? Before Java 9, you couldn't put that helper logic privately inside the interface. You either had to repeat it in each default method, which isn't great.
No, definitely not dry.
Or you had to put it in some separate utility class, which kind of pollutes the public API space. Java 9 introduced private methods within interfaces to solve exactly this.
So they're like secret helper functions just for the interface itself.
Precisely. They allow you to share code between default methods, and now private static methods too, inside the interface without exposing that implementation detail to the classes that implement the interface.
Why is that important? Couldn't you just put that private helper method in the class that implements the interface?
You could, but then that helper logic isn't part of the interface's contract or default behavior anymore. It's specific to that one implementation. By allowing private methods in the interface, you keep the shared logic tightly coupled with the default methods it supports. It makes the interface more self-contained and easier to maintain and evolve.
Okay, so it promotes better code organization within the interface itself.
Yes, exactly. It helps reduce code duplication and keeps implementation details hidden where they belong. It cleans up the interface design.
And for me, the developer using or implementing these interfaces, what's the benefit?
You generally get to work with cleaner, simpler interfaces. The internal plumbing, those private helper methods, are hidden from you. You only need to focus on the public abstract or default methods that define the contract.
Like following a cleaner recipe, as the guide put it.
That's a good analogy. You see the main steps, not all the chef's internal prep work. It makes understanding and using the interface easier and leads to more maintainable code overall.
Got it. Okay, let's shift to data. Factory methods for collections. Sounds like making groups of things easier.
Spot on. Java 9 introduced these convenient factory methods to simplify creating common collections, like lists, sets, and maps.
Maybe quick definitions, list, set, map.
Sure, a list is an ordered collection, like a shopping list items have an order and you can have duplicates, milk, eggs, milk.
Right.
A set is a collection of unique items, like a set of distinct trading cards. No duplicates allowed.
Okay.
And a map is like a dictionary. It stores pairs of keys and values, like pairing a word key with its definition value.
Got it. So what was the old way of making these, and what do the new factory methods do differently?
Well, the key thing about these new factory methods is that they create immutable collections.
Immutable, meaning they can't be changed once created.
Exactly. Once you create a list using, say, List.of apple banana, you cannot add or remove elements later. It's fixed.
Why is that useful? Why make it simpler to create unchangeable groups?
Because immutable objects are inherently safer, especially in concurrent programming, but also just generally, they prevent accidental modification. Before Java 9, creating an immutable collection was a bit clunky. You'd typically create a regular mutable list, add your elements, and then wrap it using a method like collections.unmodifiablelist.
So multiple steps and a chance to mess it up before wrapping.
Right. You could accidentally change the list between creating it and making it unmodifiable. The new factory methods like List.of, set.of, map.of give you a direct, concise way to create the immutable collection in one go.
Less code, fewer potential bugs.
Precisely. It's much cleaner and less error-prone.
So for you, the developer, this means what? Easier data management.
Definitely. You can create these small, fixed collections very easily, and you have the guarantee they won't change unexpectedly. Think about configuration data or constants. You create a map of settings using map.of, pass it around, and you know nothing downstream can accidentally alter those settings.
That provides a lot of confidence.
It really does. It reduces a whole category of bugs related to unexpected state changes. You can focus on using the data, not defending it. Makes your programs more reliable, especially when multiple parts of your code share the same collection.
Makes sense. Safer, simpler. Okay, last one. Process API updates. This sounds like controlling other programs running on the computer.
Yeah, essentially. The Process API in Java lets your Java program interact with processes running on the operating system, like launching an external application, say a calculator or a text editor.
Okay.
Java 9 significantly beefed up this API. Before it was pretty basic. Now you have much more information and control.
Like what kind of control?
You can easily get the process ID, PID, of the process you started. You can check if it's still alive. You can get information about its children or parent processes. You can even get a completable future that completes when the process exits.
Whoa, okay. More insight.
And more control, too.
Yeah.
There's better handling for destroying processes forcefully or normally. The guide used the analogy of having a much better remote control for the apps on your computer.
That's helpful. So what was the struggle before Java 9 when dealing with external processes?
It was often quite limited and platform dependent. Getting something simple like the PID often required native code or parsing command output, which is fragile. Killing a process reliably could be tricky. Interacting with its input-output streams wasn't always straightforward.
So lots of complex workarounds needed.
Often, yes. Or you'd have to rely on external libraries. The Java 9 updates brought a lot of this necessary functionality directly into the standard Java API, making it cross-platform and much easier to use correctly.
And how does this improved control help me as someone building Java applications? What new doors does it open?
It makes it much easier to create Java programs that need to orchestrate or interact with other tools or applications on the system. For example, you could build a tool that launches a script, monitors its progress by checking if it's still alive, captures its output, and maybe even kills it if it runs for too long.
Ah, like for automation tasks.
Exactly. Or integrating with command line tools, running tests in separate processes, managing helper applications. You could write a program that opens a specific file in a text editor and then waits until you close the editor. All of this is now much more accessible without needing deep OS-level programming skills. It opens up possibilities for creating more powerful and integrated applications.
Right, connecting Java to the wider system more easily. Okay, wow. We've covered a lot of ground there.
We certainly have.
It's really clear that Java 9, even though it's from 2017, brought some truly foundational changes. JPMS, JShell, private interface methods, those collection factories, and the process API updates.
Yeah, they collectively made Java feel more modern, more organized, definitely easier to learn in some ways, and just more powerful overall.
That's a great way to put it. And for you, the listener, whether you're just starting or just curious, these features really do make a difference.
Absolutely. JPMS gives you structure. JShell gives you that immediate feedback loop for learning. Private methods lead to cleaner APIs. Factory methods means safer data handling. And the process API gives you more control over the environment.
It all adds up to a more structured, friendlier way to get into Java and build confidence, right?
Definitely. It lowers some of the earlier hurdles and provides better tools right out of the box.
So thinking about all this, the improved control over processes, the better ways to organize code and manage data. Here's something to ponder. What's an everyday task you do manually? Maybe managing files, gathering information from different places, or coordinating simple steps. What task could you imagine being simplified, or maybe even fully automated, by a program using capabilities like these? How might thinking about problems this way, with the potential for automation and better organization, change how you approach problem solving in general, even if you're not actively programming right now?
That's a great question to think about. The potential is huge.
Something to consider. Thanks for joining us on this deep dive.